Hi, I'm Anton Chittey of VPG Micromeasurements in the UK. I'm going to give a review of our StrainSmart software, specifically regarding printed circuit board assembly testing. There are a few settings that you need to be aware of so that you can get direct reports for PCBA testing. I'm going to review, in this case, StrainSmart 7000. We have three other systems, 7100, 8000 and 9000. And they all have identical settings, so everything you see here will be relevant to the other versions of software. When you open StrainSmart, you should go to the Configuration tab, and you will notice firstly that there's a Settings button here. And when we select the settings, this is where we can enable the PCBA analysis. And once you've ticked this, the system will remember that you've ticked that. So for every new project, the system will have this enabled. Additionally, we have PCBA material defaults. This is where you can choose your default PCBA thickness by either picking it from the list or by typing in your own value, for example 2.0. Then you have the strain guidance equations, and you can edit these to be any function that you would like. We happen to use one of the equations from an IPC JEDEC standard, but you can change this to be a fixed value, or you can put in your own equation by putting in functions, conditional statements, and variables. Once you've set this to your desired values, this will then populate through the entire project so that your reporting will be based on these strain guidances, and you can change these at any time. Finally, you might want to set your new sensor defaults, and we do recommend that for general PCBA testing, your default strain gauge excitation should be 1 volt. You would also choose the resistance of your strain gauge depending on what type you've chosen from us. So if you're using the standard G1350s, you might choose 120. For the S5198, 350 ohms would be a good choice, so I'm going to leave that there. I'm now going to save this, so those settings will now be relevant for every single new project that I set in the software. So we want to set up a new project. So we're going to start off by clicking New. And this will then ask us if we want to save what we've done so far. In this case, I don't have anything set up in this particular project. And I'm going to use the New Project Wizard, and this will step us through the setup process. I'm going to click Yes to this prompt, and the system will then create a fresh blank project ready to populate with our information. First page of the project setting, it does repeat this Enable PCBA analysis, so it does give an option to switch it on at this point if we forgot to do that in these settings earlier. Click on Next, and we can define our sensor types. And for the majority of PCBA testing, we're using rectangular rosettes, and this is where we take information from an engineering datasheet. We would have, for a typical rosette, 3 gauge factors, 3 lots of transverse sensitivity, some optional information, and of course this resistance and default excitation that we set up in our settings a few moments ago. Once you've set this according to the sensor that you have, click Add. And in this case, I just need 1 rectangular rosette. Click Next, and we can then create a new material. And when I click this button, it picks the defaults that I created in these settings. So this is the 2mm that I typed in, and using the strain guidance equations that we spoke of. I'm going to add that material to the project. The next step on the New Project Wizard is if you're connecting to the hardware for the first time, you can click Connect and Detect Devices, and it will go off and look at the hardware and populate this screen with however many scanners and the types of cards you've got in there. In this case, I'm not actually online with the hardware, so I'm going to skip this step and just go Next. And then this is where we create the assignments. So what I'm going to do is I'm going to select a channel where my sensor is connected to. So this particular sensor, I'm going to have connected channels 1, 2 and 3. So when I click on, or right click on channel 1 and add the rectangular rosette that I created a few moments ago, it automatically assumes I want to connect this to grid 1 on channel 1, grid 2 channel 2, grid 3 channel 3. It's also automatically picked the material. If there were more than one material, I might have to choose it from a drop-down, but with one material it does automatically select that. If I have more than one rectangular rosette, I can just click the plus, and it will assume you've then got concurrent channels, so therefore 4, 5, 6, 7, 8, 9, 10, 11, 12, so you can go on adding more and more assignments, assuming that the sensor and the material are the same across these assignments. In this case, I've only got one sensor attached, so I'm going to remove those. I can ignore the rest of the settings. I'm going to click Save, and I'm done. What I could do at this point, of course, is name this particular assignment. So, for example, I could say it's Rosette 1 on BGA 1, for example. So I can use this when I do my reporting to keep track of what sensor was connected where on your printed circuit board assembly. Click on Save, click on Finish, and that is the setup of the project completed. What it then asks me to do is create a new scan session. In other words, tell the system how to record the information. So I'm going to say yes to create a new scan session now. And it will then start the new scan session wizard, and notice that any assignments that I've created will automatically appear ticked in this list. In other words, everything that's ticked will be recorded. I click Next, and I can choose my scan rate, typically between 500 and 2000 samples per second for the IPC-JEDEC standards, and I'm going to click Time-Based Recording. And for the type of testing I'm doing, that is all I need to choose. So I'm going to say Finish, and that's my new scan session set up and ready to go. We're now ready to connect to the hardware. So I've powered on the hardware. I need to find one of the connect buttons, either at the bottom here or up at the top. And when I connect this, it does a connect and detect in a similar way to it would have done in the wizard had I had the system powered up. And you can see that it's successfully connected. If there are any issues, then it will give you a list of the problems, and you can resolve them by reconfiguring hardware or reconfiguring in software. From this point, I can go to my Open Sessions tab, and you see that some buttons have highlighted here that were previously greyed out. I've got my zero balance button, where I can set the zero of my sensors, and providing everything's good, I should get a zero complete, so there's no errors or warnings there. We then have our shunt calibration, where it will provide the shunt calibration process that corrects for lead-wide desensitization. And that just takes a few seconds longer than zero, as it's taken an actual measurement on the sensors now. And it says shunt calibration complete, and again, no errors or warnings. At this point, we can arm and scan the system, but we have this validate project, and this just sees whether there's any errors in the project. And then I can click arm, and this sets up the system ready to start recording data. And if there are no issues, then the scan button will come up, and the system, because I told it to record at scan rate as soon as I press start, it's now recording data, hence the time recording button is highlighted. And so this is now recording at 2000 samples per second. I'm just going to tap my PCBA in my test rig, and then I'm going to click the stop button at the end of my recording process. And this will automatically download the data from the scanner and add it to the project. If I want to progress to another test, so I could repeat a test on a particular workstation 3 times, I can click yes, and this will copy across the recording modes, the zeros and the cals, so I could continue recording by just clicking arm and scan and starting again. But at the moment, I have actually recorded data, so I can go to completed sessions, and here is my scan session 1 in the list. Now I can rename the scan session to, for example, say ICT1 for an argument's sake, and click save, and then I can double click and this will open up the data. It will give me a choice of what I want to review, and in this case I want max, min and diagonal, And let's get rid of angle. I'm not interested in that in this case. And I can set these defaults here by right-clicking and saying save as default rectangle rosette assignments, which means next time I run a project I won't have to tick any boxes again. I then can say select, and I can now review the time-based data. You can see here I tapped the PCBA 5 times. You can look at your strain rate chart to the IPC JEDEC standard, where here's all my data and here's my strain metrics, or my principal strain, maximum principal strain guidance. Or I can bring up the PCBA strain report, and in this case it says that I've passed everything. It even tells me where my peak strain was and a percentage of my strain guidance, so you have a very good pass in this case. From this reported data, we could realise perhaps that our strain metric isn't quite what we wanted here. So we can edit that easily by simply coming out of the data display, going back to configuration and finding the material that we defined earlier, and change these equations perhaps to maybe 500 microstrain. I'm going to edit all three of these, so max, min and diagonal. And what that will do is it will enable us to immediately go back to our completed session, double click, agree to the selections and click on the strain rate chart, and now we have our 500 microstrain strain metrics, and so we've got our new data and our new reporting as well. So now here our strain guidance is 500. So our percentages may be slightly different to previously, but we still have a pass. Once you've completed all of that, then you should make sure you save your project. And this will save everything, including all of your scan sessions, both open sessions, completed sessions, all of your configuration. So if you want to do more testing, all you have to do is go to open sessions, and as long as you're online and connected, which I've now switched off my hardware so I'm offline, but I could just go back to here and I could go back through 0, Cal and ARM to do further testing. Finally, just to reassure people who are using other systems, maybe 7100, 8000 or 9000, I just want to show that the software is indeed identical. So you can take everything from this particular video and apply it to your other systems. So here we have our 7100, and although I've changed the skin color using this menu here just to remind me this is for 7100, you can see that the settings are identical. You have the enabled PCBA analysis, you have the material defaults, so you have everything that we talked about earlier. If you look at system 8000, again, you'll see in configuration we've got the same settings, the same PCBA analysis, the same material defaults. And then for system 9000, we also have, again, the same settings, enable PCBA analysis, the same material defaults. I can actually reset those to the application defaults if necessary. You notice sometimes these are different because I've been using them for different applications. But you can see that these three pieces of software here are identical to the piece of software we used in the video. I hope you found this useful. If there are any questions, please don't hesitate to contact me or one of my colleagues.